So the second half for the afternoon talk will be about Git and using that for version control. The people that know Sage know that so far we're basically in the dark ages and mailing patches around. That works always surprisingly good, but then also sucks in a surprising number of ways. And Git is a way to automate things that you don't screw up as often as you would do with patches. I know I always get the wrong version of a patch, and then on different computers the different versions, and it's very confusing to me. And so we decided to move to Git. This is not finished in the sense that the official latest Sage release is not using Git, but hopefully the current beta will be the last one that uses Git, that does not use Git, and from then on Sage version 6 point something will be just using Git. So my plan is just to talk first about Git in general without even thinking about Sage, and then explain how that ties together with Sage and the kind of development that we do. And at the end, there's also some script support in Sage that's not entirely finished yet, but reasonably usable, and I'll show you that too. So since some of you don't understand British English, it was a loss to me for a while, but Git is actually kind of a bad word in British English. And so I'm more used to American English, and there's like get it done as just slang. It's nothing bad, but in British English it can actually mean something bad. And just to be sure which one it is, the landing page is very explicit about it. So okay, the kind of reason behind it is of course more jokes. So Linus Torvalds started using that. Okay, I name all my programs after myself. First Linux, now Git. Fine. So why should we use Git and not something else? It's not the only distributed version control system, but it's by far the one with the most momentum at this point. And it's of course always an advertising question, what is the most popular one? But by some reasonable measure, it's becoming the most popular version control system maybe this year. And what's the guiding principle behind it? It's distributed. There's no central point of anything. So what you do with on your hard drive is as relevant for the whole repository as what everybody else in the world is doing and what is on the Sage server. And then of course the version control system, the means literally that we manage changes of documents in a way that's more safe than mailing patches around. And well, if you have never seen it as a web page, it's free and open. So it's an open specification. You can implement your own, or you can take the existing implementation. There's more than one existing implementation, but there's at least one official one, which is a command line program. And as I said, I'm kind of a command line child. I like and this command line implementation is really fun. You don't really have to use it. There's graphical user interfaces. I'm gonna show you Git G, which I like, and Git Cola is also nice. So if you wanna have some suggestions for something to try out, look at those. But there's lots more. And then there is, of course, this distributed only is really useful if you can send each other stuff. So, and to send each other stuff without having to go to work around your own firewall and whatnot. You want to have some hosting. It's not centralized in the sense that you can have many hosts and many remote repositories, but it's a way to easily exchange things between different repositories. And in fact, if you're a member of the institute here, we have our own Git server, so you can go there and make your own repositories. But then there's GitHub. I'll use GitHub because it's perhaps the most famous one, but there's no specific. I'm not endorsing it over any other Git repository. Okay, so just to make this more entertaining, I'll give it a more personal touch. Okay, so here's my talk is in this directory, and let me start by erasing it. Then the talk is gone. So that's the usual case. You type some wrong command and you screw up the. What are you gonna do now? Your source code is gone. Of course, not if you have backed it up. You do make backups, but here I've got a repository on GitHub where I checked in my text source code as I was writing this talk, and it's here. So I can just go to this web page where you can also get the source code for the slides. We copy this URL, then go to economy, git clone, and then it runs for a moment and pulls down the whole source code into a directory that's called talk git sage workflow. I can rename it to anything that I want, so let me rename it to talk git again, and then so here's my talk. Of course, I only checked in the source code. I only check in the text source code. I don't check in generated PDFs and the whole slew of files that tech is generating. That's similar if you do program. If you write a program in C, then you wouldn't check in your object files. That's just auto-generated. You only check in your source code. So we have to run pfidec or talk. And then it will compile, except, okay, some idiot messed up the text source code. Who was that? So let me show you git g, and I like it. And, all right, so then it shows you the line of development. I'm the only one who wrote the slide, so what was the last change? And what was the last change here? Okay, that doesn't sound good. It shows me the changes. Probably that's not a good idea. Why? Well, of course I did it to show you how to see the changes. But if every time I upload stuff, I add to the repository, it adds a snapshot to the repository, and I can easily then change the differences that every one of those commits made. And I'll quickly identify stuff that I don't like. So this was probably a bad idea. I should go back and instead of using this version, use the previous version. So various ways to do that. One general way is to organize development into branches, which you can think of like branches of a tree. So I'll just branch off from the previous state into a new branch, which I call working, because it's working, I hope. And okay, the git-g doesn't actually change the working directory. It's really only to see the revisions. But now I'm back on my command line. And there's now an extra branch that has opened up. I can switch the branch. And now all the files are switched back to one version before that. Of course, it was only a one-line change, but that's it. And now there's my talk back, everything, the whole source code. So let's take apart what happened. So there are as I said, there are these snapshots. That's basically what version control is. You want to have snapshots that you store for later to go back to those snapshots if you want or if you need. And they're not just snapshots, they're organized into a direct acyclic graph. So since that's probably not that's maybe the way to explain Git to mathematicians, but not for the lay audience. But that's the precise structure that we use commits from. So commit is just a snapshot of all your files. You only go forward ever. There's no going back. Once you have committed something, it's in the repository. You can change it and add new snapshots, but you can never go back and change a snapshot that you already made. And that's precisely what you want in a version control system. You don't want to have one snapshot over here and a completely different snapshot on your laptop, and you don't know which one is which. So you only go forward. That's the directed part of the directed acyclic graph. That doesn't mean that you're forever stuck with one. You can definitely abandon commits, but it's just once you create them, you can't change them. This graph thing, usually, and since when I create the slides myself, then there's only one parent for each commit. Whenever it's just me, I add a slide, I commit the change, there's one parent commit to this commit. But that doesn't have to be always the case. There can be multiple parent commits, and that's called then merges. So you can have different branches of development that you want to join together, and then you have merge commits that have more than one parent. So that's where the graph comes from. It's not just a line, it's really a graph. And then you say, okay, if you call multiple parents a merge, and what do we call multiple children? Since it's symmetric, we can go back in time or forward in time. But there's no special name for multiple children, because you can always add children later on, and if your commit has only one child now, tomorrow it could have two children. So doesn't really make sense to give it a special name. Versus merge is always well defined. You can never add more parents to anything. Okay, so here is I showed you the repository view for just my slides, which is of course there's only me, so there's only one parent, one child. The kind of safe development that we're currently using, there's of course different people working on different tickets that are being merged together. So here's some particular merge that has a bunch of parents merging it together to fix some ticket, and that's normal. And you get some sort of graph. GitG shows the graph with time going upwards, and that's it. And then all the histories in the repository, you can take your favorite log viewer, GitG in my case, and dig around in it. Alright, so good. So that commits are snapshots, then what else is there? These snapshots are part of the actual Git repository. There's one Git database of all the snapshots and associated metadata. And that's all in this .git subdirectory that you'll find if you have a Git project. But that's not all. There is also two more places where you store files, and so one of them is pretty clear. There's also the files that you actually have on your hard drive as you write your code. You don't really have to have those files on your hard drive in order to work with the history of the Git repository. And in fact, if you have a Git repository on a server, then you don't have the working path. There's no working directory. But when you use it on your laptop, then there will always be a working set of files. In this case, in our case, the whole sage tree. And then there's also this mystic staging area. So it seems like two places to store files would be enough: the repository and the working directory. But there's a third one, the staging area. and that's useful to decide which files to commit. So the staging area is you move files from your marked files that you change as ready to add to the next commit by using git add or your favorite graphical user interface line. That means that you add them from the working directory to the staging area, and then commit moves from the staging area to the actual repository. And so this is like an extra step. Why the extra step? It just turns out that it's useful to not have to commit everything that you change. Sometimes you change something and you think, I shouldn't commit that, I'll commit that sometime later, because that's somehow a different file. And by separating the work file from the staging from the repository, you can easily pick which files will be part of the next commit. And you can see which files will be committed before you actually create the commit. And to see which ones are staged, which changes are staged, you use this git status. So these are probably the three most used commands: the git status to see what's changed, then git add to add your changes, to change files to the staging, and then git commit to make us turn all the stage changes into a commit. And I'm just saying git reset is the undo. You're resetting the working. Git reset always resets either staging or working directory to a previous state, and to remove something from staging, you reset the staging. That's the language that's been used. All right, now good. We want to say we have made our changes, we add them to the staging. Now we want to make our commit. There's importantly a message that goes with the commit that tells you what you did. Like I removed begin document for some reason. The reason should be in the commit message. That's the whole point. That you don't write down I changed the file matrix.py. That's clear. Yeah? We have the commit contains the changes, so we don't need to know which files you changed. We need to know why you changed the file. So that's the commit message. There's a kind of a one-line abbreviation with the -m. Lots of there's various command line switches that to simplify things. If you just do git commit, then an editor will pop up, your favorite editor that you have set, or not. Then if you haven't set it, then some ugly abomination will come up. But that's it. But if you don't want to use your editor, you can also specify it in one line. And
also multi-line message is no problem.
I think so.
Yeah.
And I always tend to use this if I'm just having a short commit message. If it's like editing a whole bunch of text, then I usually don't use the shell to format my text. I'll use the editor, and I set my desired editor. But I get it. Okay, now so the commits. One thing that you'll learn very quickly about the commits is that they have something to do with 40-digit text numbers, because that'll always print out. And these 40-digit text numbers are SHA-1 hashes. They are hashes of the changes to your files. So, which is good, knowing the SHA-1 and telling that SHA-1 to somebody else. So it defines that those changes are the ones that you want. But there's more. Also, the parent commits go into the hash, and the actual commit message goes into the hash. So, in particular, none of those can ever be changed without changing the hash. And in particular, since the parent hashes are also in the hash certifies that all your changes are the ones that you want, all the way up to the beginning of the repository. So it's not just the hash doesn't just tell you that those were your changes, but those were your changes to this precise version of all the other files in Sage. And yes, you can't change it. You can make a different commit if you want. That's fine, but they'll have a different SHA-1 hash. Okay, good. In principle, we only need commits and work with those. In practice, that's not terribly convenient to type 40-digit hex numbers. So in practice, we have those branches to organize the development. We should have some nice name that you can actually understand. But at the end of the day, a branch is just a pointer to a commit. It's not it's not exactly the same as a commit, because as you continue your development, the branch pointer will move along with the commits. You have a branch, you add a commit to it, that changes the commit to which your branch points. Now, after you commit, the branch is also advanced, points to the new head of the branch. You'll see master often as a branch name. That's the default. It's nothing special about it. It's just the default. There's some abbreviations for special commits. So head will always come up. It's just the head of the commit. The SHA-1 of the commit that your branch is pointing to is called head, so you don't have to type this particular 40-digit hex number all the time. It's just a useful one. And you'll see the twiddles, head twiddle, n. Those are abbreviations for the parent of the head and the parent of the parent of the head and so on. Just good. So that's basically how your development will look like locally. You have a bunch of branches for whatever you want to do, and you use git checkout, as I showed in the beginning, to switch between branches. You commit stuff, you move on with your branch. The fun part is, of course, now that we can communicate the changes to branches to other developers, and for that we'll have those remote repositories. At the core, a remote repository is just a bookmark for some other place. So it's a bookmark for a server like GitHub or the Trac server for Sage. And in particular, you often think, I would want to have the different, what's the difference between this file in the remote repository and my file here? That doesn't make sense, because a remote repository is just a bookmark. You have to check out the remote repository, and then you can do file operations. Okay, now I'll just throw around this git remote command. I'll go through the precise details for what the right git remote is for the Sage development later on. There's nothing special about the different. You can have as many bookmarks as you want. There's none of them is better than any other. You can, one name again that comes up often is origin. That's just what often is called, that's the default, so usually it's the one that you use the most, but doesn't have to be. And we kind of recommend that you use Trac. In our documentation, we use Trac as the remote name for our Trac server, but you can use any name that you want. Okay, then why remote? Because we can upload and download changes from remote repositories, and ideally we just say git push to remote, and then your changes will be uploaded to that repository, and we say git pull, and the changes will be downloaded to your local repository, and your local repository will be moved forward to whichever changes were made to that branch. So in the simplest case, that's really good. And especially if you develop something on your own, you just commit occasionally, and then when you wanna, at the end of the day, when you wanna make a backup somewhere else, then you say git push to my remote, wherever that is, and then I would make a remote backup. And if you move from your laptop to your desktop, then you do a git pull, and it'll pull all those changes and move you to the same place where you were on your laptop. And then, of course, there's information you can get about remotes, like which version are they currently at. This all goes through the git remote command. There's a default, so often you just see people say git push, git pull. That's because they have a default set up. So I just wanted to mention that. So that's the easy part if there's no conflict. But
so push and pull commands, so do they also push and pull uncommitted changes?
no, they only. Should I show you? I'm not going to show you the graphic. They only work on the repository. It's what.
So would at least be a warning issued if you have user changes?
Perhaps you're gonna try that. There's probably a command line switch to a change. I don't know on top of my head. If you git pull will update your working directory, of course. That's what we want. The events push with unformatted changes is fine. Maybe it shows a warning. But you should be able to push without. We tried out this out. Usually, yes.
Is there an analog of the Mercurial incoming and outgoing commands which almost do it but don't actually do it?
You got fetch, which just gets changes but doesn't merge anything.
Yeah. So okay, I didn't want to take apart fetch and merge yet, but pull is fetch and merge things, get changes and merge them into your repository. I'll come to that in a couple of slides later when we talk about the Trac development. I don't think there's anything that you can't do. There's nothing really that you can't do with Mercurial that you could do with Git with some distributed version process. It'll have some slightly
very
different
similar
flavors. But I mean, it's like this it's different, but it's all distributed version control. I just somehow, right now, it's probably fair to say that Git has an order of magnitude more users. So, if you wanna, I'm not saying this you should use Mercurial, but if you wanna have the larger number of users on your site, then you should use Git. And I think that's one of the criteria that we really use why we wanted to use Git. Right now we use Mercurial, but using quotation marks, we don't actually use it. We could have used Mercurial more properly, but then that's exactly the same learning curve as learning Git properly. And since everybody and his dog are using Git right now, it just makes more sense to move to Git.
Do you think there's any technical reason for Git being so much more popular, or is it just GitHub?
I don't see. I don't really see a technical reason. I see Git is a little bit closer to the nitty-gritty parts. So if you wanna script Git, then that's much easier than write a shell script around Mercurial. Git has all kinds of hooks. It already expects you want to script it, and since you want to script it with for simple development tasks, anyways, I wouldn't know how you get null-terminated strings out of Mercurial if you want to wrap something into a C interface. In Git, that's easy. It's already in there because it's expected that you're going to wrap that around something. These commit hashes are really first-class things. There's a larger, higher, steeper learning curve. You get immediately confronted with hashes and whatnot, which usually people don't bother about. But then it kind of grows on you. Once you realize that a commit is just a hash and it's a really convenient way to specify a particular commit, then it actually, once you make that connection mentally, it sounds like a good idea. And that's, I think, what's behind the adoption rate of Git, that people realize that maybe it's a little bit harder to learn, but it doesn't hide anything from you. You actually see what you're doing, and it's clearer what exactly is going to happen if you are the command. Okay, so conflicts are just a fact of life in distributed development, because you cannot avoid conflict, and the number one design goal in Git is to make conflict resolution work, because that's what distributed version control is about. Mailing around commits is sending them to some remote server. That's not that exciting. The exciting part is that you can easily push things together, merge different branches together, find out what the changes are, and resolve any conflicts. And so where do conflicts come from? I'll run you through some nice examples. For example, we have here some text file that somebody wrote. I'd say I wrote it for the sake of the argument, and okay, it's just some snippet, because that's how that's how patches work. They look at a little bit of context around changes that we look at, and that's basically how the conflict resolution works. It will look at what really changed around the file and distill out the changed line and hand that to you. So here's a line with a little bit of, we'll be looking at this line and a little bit of context around it. And then I realized that, okay, there should be two roots of the quadratic equation. I should give them an index. There's not one. So I'll write x, instead of x is equal, I write x is x12 equals. Sounds great. And then I'm on my airplane to somewhere else, and at the same time Jennifer goes ahead and sees, okay, you shouldn't use plus minus, that sucks. You should use a proper text marker for plus minus, and then she pushes that to our shared remote repository, and then we have a conflict, because we both change the same line. There's no way a computer can tell which one is better, and in fact none of those is better. The kind of the union of those is what you want. You want to have both the extra indices and the plus minus. So what happens now, of course Jennifer it's easy for her, because she was in her office and could push to the remote repository, and when she pushes, the remote repository doesn't know anything about the conflict. The conflict only appears once when I step out of the airplane and connect back to the internet. And then when I push, it'll say, well, you can't push because there's a conflict. And it's my responsibility to resolve the conflict, because, well, in a sense, I'm the first one that brings up the conflict. And it actually tells me, well, what to do is that I merge the remote changes with git pull. For example, if you do git status, then it will tell you again the same. You have to do git pull or something like that to merge the changes. And then I, of course, write git pull because it told me to. And if I'm lucky, then this will work. Like if we change different lines that are sufficiently far apart that there's no overlap in the context, then this will be merged automatically. But since we changed the same line, there's no way to automatically resolve that, so, well, bummer. And what happened is, Git shows, it tried an automatic merge, failed, and the file now looks like this. There is this marker. One line is the change that I made. One line is the change that's currently in the repository. And then for good measure, there's also the hash of the last common ancestor that we had. And, well, okay, so now it's my turn to resolve that. How do I resolve that? obviously I can open that file into an editor and delete all of that and make my own merge, whatever that is. Or there's various programs that help you do mergers in a graphical user interface way. So I like Mel. Who has never heard of Mel? Well, it's a simple three-way diff viewer. There's a bunch of them. I like this one. It'll show you the line. This is the central one is, well, obviously the one that's the new version. That's what is gonna be the new version. It currently shows you the last common ancestor, and then there is my change and Jennifer's change, and now I can click one of those arrows to propagate the change, or I can manually edit the line in the middle to make it what I want it to be. That's as far as the automatic tool goes. They show me where the conflict is, but to actually resolve it, I have to use my own judgment. In any case, then, whichever you resolve the conflict, you do both the changes, the indices and the plus minus, and then that's it. Then we add it to staging and commit that, and finishes our git commit, merge commit. And now I can push that to the remote repository because it's now the conflict is resolved. And now when Jennifer pulls that, she doesn't have to resolve that again. That's the whole point of distributed development. You only need, yes?
Stupid question. You can't go back and change the commit comments, can you? Like put an apostrophe in Jennifer's or something.
You can. There's amend, just like in Mercurial, but that really just throws away the last commit and makes a different one.
Okay, it's just the last.
So you can also manually throw away the last commit and make a different one. That's the same as amend, but you can't really change it.
Does the hash include the message as
Yes.
well?
And then maybe a good, just to sort in, sometimes you end up with you merged the wrong branch in it, and now you have a gazillion conflicts, and you want to just go back, and so there's merge abort, this is abort bailout, and not do anything. Then okay, here's git G again to show you the history, how it now looks like. There was our last common ancestor, and then Jennifer made a change and I made a change, and then I merged those two together, and now the directly acyclic graph has this one loop, and there's one parent that has two children, and one merge which has two parents, and the development is back in online. Okay. So there should be the outline. That's not there. Okay. So this was just showing you how to resolve a commit. Resolve a conflict because you're gonna inevitably run into a conflict, and you shouldn't be scared of that. It's not difficult to resolve conflicts. Now let me.
Tools that try to merge such changes automatically, that look at parts of the line.
If it can be automatically merged, then it will be automatically merged. Like if the context doesn't overlap.
Yes, but I mean for this example, it's still possible to see that the changes are in different parts of a single line. Can Git try to include both of these changes, or it never works on sublines?
I think the automatic conflict resolution really looks at a couple of lines of context, that just like patches. There's the algorithms are similar algorithms that are flying around for patches. Maybe it's a bit smarter with white space than the plain patch command, but that's about it. You don't really want to just look at a letter of context, say that will too often screw up and patch your change in the wrong place. So
I think the suggestion is to have several lines of context, but still be able to merge the conflict that only happens in one line, but in distinct places of this line. And I mean, you're right. I mean, this the two-line context tells you which line you are actually changing, and then within this line, there's still a context that shows you that it is, in.
But it's still. I mean, of course, a lot of you could do things that are more fancy, but it doesn't strike me as particularly useful. Like somebody changes a sign and somebody changes a 2 to a 3, and then it's not clear that changing +2 to -3 is the best merge of those things. That's likely to be the worst choice, because neither of the two authors had that in mind.
But a related question, I mean, you said something about this Git merge tool. How to customize this?
Git merge tool, I think by default just asks you which one you have, unless you have only one. Then, and there's a command, there's a -- tool, and then a list of supported tools that you can have. There's also Git merge tool help, which will pull up the man page for you, which will tell you exactly what you're doing. There are, okay. Maybe it's worth saying that any Git command, I wanted to say that at the end, but anything Git command help will bring up the useful help for that command, subcommand.
I mean, I expect that there's some, I don't know, .gitrc file or so on which you can put the default merge tools in.
Right. And actually, so okay, since I'm now switching a little gears to talk about the Sage development, one thing to configure is your name and email address that you want to have in your commit messages. So there's 2 ways to configure Git in general. There's git config, which is a text file that you can edit. And to configure your name and email, you write it in there. Or you use the command line git config, the setting with the value, and that also works. So you could also use that to git config merge tool or whatever you want. And that's probably the first thing that you want to do before starting. You definitely should do that before writing your first commit, because if you commit with some stupid name, then you can't undo that. It's part of the hash, and to change it, you actually will change the hash.
Particularly the default name is Git, because then you are Git.
All right, then the Trac account thing. You don't need the Trac account to download stuff, but you definitely need the Trac account to upload things to our server. So if you don't have one, there are instructions on trac.sagemass.org. Why not have a Trac? Why not apply for a Trac account now? There's some. It's not difficult to get a Trac account. The difficulty is you don't want to have too many spammers that get accounts and then you spam links on our wiki. So this is just a formality to keep the people that have accounts and can change the webpage to a finite number. The transport, so there are various ways to do transport for Git changes. The one that you have to use with the Trac server is SSH. That doesn't mean that you can log into the Trac server, it just means that you need to give the Trac server your public SSH key, not your private SSH key. And then it'll authenticate with that. And there's work in progress development guide for Git here, and the details, like exactly how it looks, where you have to, how you can generate a SSH key and so on, describe that. Or just ask your neighbor. I'm sure everybody here has used SSH keys before for authentication. Good. Then you have to get the, so if you want to use this Git development, you need to get the sources. For example, you can clone the GitHub repository for Sage. You can also clone directly from the Trac server. That's probably going to be a lot slower than GitHub. The repository itself is about 60 megabytes or so, so it's not trivial, but our server is not super fast. Yes.
So is there an official central copy that is it the GitHub one, or does William Stein maintain it, or?
In the official, there's no, I mean, this is distributed, there's no really official, it's just a label that we would give something. Right now we haven't actually made a Git release. It will be I think the official one will be the GitHub one, just because.
Okay, but on Trac, when you write a comment, for example, that this has been checked in,
Yes.
So where has it been checked in?
Well, you don't have, maybe I'll say something about reviewing later on, but you don't have to say that, because when you upload something, you say this is the head commit of my branch is this SHA-1. That is all. That tells you exactly which
Okay.
source tree layout you have.
So let me put it another way. There has to be some kind of convention about this, because if you write it on the ticket, okay, I've submitted this patch, I've solved the problem, and now I want to get that patch. I mean, where do I get it from? Do I ask you for it? Do I get it from the Trac server?
So the Trac server also has a Git repository. So you can always download the Git tickets that use the Git workflow have a branch attached, and that is the name of a branch, and you can download that branch from the Trac server.
Okay.
And
then the release manager is responsible for putting them all together.
Exactly.
Okay.
The release manager will then just have to git merge, and then tag that as a release.
If I understand correctly, it is possible to take a branch from Trac, which may be based on the repository on Trac and then you can merge in what is on GitHub, isn't it?
Right. So the GitHub repository on the one on Trac are basically they will be synchronized. So
Yeah, but they currently aren't.
yeah, they currently are. So the GitHub repository is slightly older, and it doesn't have all the bits that you need. That's kind of a, for the transition period, a pitfall that you can't just use the GitHub repository, because that doesn't have all the things that you need to build it with the slightly changed directory layout. And so to actually build it, what do you have to do? You have to get what we currently use as master, and what will at one point be the official master. Probably not soon. Hopefully not too far in the future. And okay, so first you have to set up the Trac remote. Starting with this means GitHub is its origin, so of course you can rename it or anything. We'll add Trac as a remote, and this is the command. It's also in the, you don't have to write it down, this is in the developer's guide. And the slight change to point out is that we kind of recommend that you use this -t to track only a particular branch. So you can, if you want, track all the branches on our Git server. That means then all the tickets that will ever be created. If you pull all this data, and it'll just make things a little bit slow for you. You can do it. We recommend that you do this -t master, so you only track a particular branch. The advantage is there's no clutter, and you don't download all the tickets. The disadvantage is you're not downloading everything by default. So we can change from what I talked before in the workflow I talked about before, which is a little bit simpler. You just pull and it pulls everything. We recommend that you set it up so that you only pull a particular branch. So if you want to work on a ticket that's in some on a branch that's associated with some ticket, you only pull down the branch that's on that ticket and not everything under the sun.
In order to avoid confusion on the side of the user, in particular of myself, there is master both on GitHub and on Trac. How to rename it on the local repository to make it easy?
So they will be in sync at one point. So this is not neither of those masters is the one that we currently can use. So for the let me show one more slide and maybe we'll talk about it again. So for now we don't use master, we use this branch called public save git master. And that's our integration branch. This will become the next stage release, but it's still being worked out. It hasn't, not all the changes have been reviewed.
Hang on, where to find this? I mean, is this GitHub or Trac in this public stage?
This is on Trac.
Uh-huh.
So in particular, to get this branch, you will write git fetch Trac public sage git master. This is also written down in the developer guide, so you don't have to write down. But fine. And as I kind of almost said before, pull is fetch plus merge. Here you have to do the fetch part manually, because if you just say pull this and that, then your local Git repository has never seen that. You have to first tell it to actually look at the remote repository. This is the thing that I said before, that we want to set it up so that you only look at a particular branch. You have to actually specify which branch you want to pull down, you want to get from the remote repository. And if you set up the remote like this, then you have to first get it. This fetch makes a local copy of that remote repository, so you can then later on use it. And then in a second step, you can turn that downloaded copy into a branch, so which would be this checkout -b to create a branch and give it some name, say Trac master, but any name that you want. And then you would have to specify the branch that you just downloaded, which you can specify by its 40-digit SHA-1, or there's one of the abbreviations that Git writes is fetch, which is the SHA-1 of what you just fetched, the most recent fetch command. And so that's it. That will give you a new branch. It'll switch to a new branch. So you check out and -b together creates and switches to that branch, and this will give you then the branch that actually works. So one exercise for later today is try this. This is the actual commands are written in our developer guide, and if you do, after you do this, you have a set of sources that you just then have to run make, and it'll do.
Will tests pass?
Yes, all tests pass, at least on my computer they all pass. If they don't pass for you, then tell me.
Will the developer script?
The developer scripts are also included. I'll talk about the developer scripts in a second. So that's why I said this is the integration branch right now.
So I think something like 2 weeks ago did not go to this.
Yeah, there was some progress. But this is, I think, basically release worthy. It's the last stage. It's based on the last stage release, 5.12 beta 5. It has that. It has the developer scripts. It has all .test pass. So it's pretty close to what the next Git release should be. And once the Sage Git is actually finished and reviewed, then this will become master, and you won't have to jump through those hoops. So
So when build stage as usual, what about packages?
optional packages
Or
is
standard packages?
all standard packages are in there. The format has slightly changed. So
And it's
I
still
might as
only
well.
60 megabytes?
Huh?
So why then it is only 60 megabytes?
So
compared
that's
to-
the S packages system has changed. Now we ship the install scripts with Sage, but the tarball is separate. So when you run make, it'll connect to the internet and download the tarballs for the various packages. There is there's supposed to be a make download or something like that will just download them. So you can then build it when you're disconnected from the internet. I'm not sure if that works yet, but the idea is that we don't ship Sage with all those tarballs. Okay, there will be an official Sage tarball, of course, that has all the individual tarballs already included, but the Git repository doesn't know about the tarballs for a third-party code. But it can download them automatically and will check the checksums. The repository has checksums, so when it downloads stuff, it'll know that it's actually the right version that it downloaded and was not.
And so particular upgrading SPKGs will be easier because you don't need to put the tarball into the SPKG, but you just need to update the pointer to the current version of the third party.
In particular, there's only one repository. There's no one repository per S package. There is only one repository. All the data is in the main repository, but without the actual tarball. The hash, SHA-1 or 512, I don't know, of the tarball is in the repository, but not the actual tarball. So when you build it, we host the tarball, so there's no question about 50 different hosts having to be up. It's only Sage.math has to be up when you build it. But the tarballs are not part of the repository, only the hashes. And then upgrading should be much easier if you write a patch. You can write create a new branch. That new branch has the new checksum and any changes to the S package installed also. And that's it. It will be a tiny patch that will be applied and become then part of the repository.
And if I'm not mistaken, the optional packages are not moved yet.
Yeah, optional packages are not moved. At least for a while, we're gonna support ghosts. So you can have old style optional packages that are just tarballs of stuff that gets run and that has an installed script in it that gets run. But they're also supposed to transition eventually to this format. So
since there's some default infrastructure or something that the maintainers of SPKGs can use.
Optional packages will be exactly the same kind of as the standard packages as far as the Sage repository is concerned. There will be a tarball, the checksum of the tarball is checked into the Git repository, and the only difference is that they're not being built by default.
But the build scripts of optional packages will be in the standard
yes.
repository.
Right. Right now they're not, but that's one task if somebody wants to attack it during your stage day is try out all the optional packages and find out which ones don't work. The directory layout is slightly broken, so if optional S packages that hard-coded part of the directory layout and didn't use our environment variables might break, and we'll have to figure out which ones those are and update them. But that should be fairly straightforward. Okay, good. So how do we tie the Git branches together with the Trac? I hope everybody has seen Trac. It's just the web page that we host that to keep track of change, like bugs. I think Jennifer showed it. It's like a bunch of comments. There are numbers for tickets. For each ticket, you can comment. You can say this is a stupid idea, or this fixes the issue for me, and then. But this has to be tied together with Git, and this is how we tie it together. On Trac there's now a new field that's called branch, where you put in the name of the branch that you want to use on our server, on our base.
Meaning the SHA-1.
No, name meaning the your Trac username / some description. If you want, username has to be your Trac username. You don't have any freedom there. Description can be the Trac number or some name that you remember, or whatever you want. You can even have slashes in the description to make it more hierarchical, but that's all up to you. The only thing that we require is that it starts with you, my user, and then / your Trac username / anything else. And then you'll have your local branch of some feature, then you can just upload it to that remote branch name. There it's important that your local name can be anything, but the remote name has to be this you / your Trac username, because that's the only place where you actually have write permissions. And so if you want to push it to anything else, then it'll fail. But you can create new branches on Trac that start with you / your Trac username. And so this sets this as a default. There's a slightly different version for the subsequent uploads. Doesn't matter if it's head or my branch, but you should only set the upstream ones. Anyway, this is again this is in the developer's guide described. And it's maybe slightly strange that I'm advocating you to first fill in the branch on the ticket that you want to name it and then upload it. The reason is that we have a script that will, when you push it, it will look on Trac for a ticket that has this branch and then update it. It'll give you a list of the changes that you made. And if you don't first fill in the branch, then the script doesn't know which ticket you're using. Does that make sense? Nothing here, when I'm pushing this, tells the Trac what ticket this is supposed to be good for, unless you filled in the branch first. So if you first fill in the branch, then push it up, then the script will know where you want it to apply to. And so one thing that the script on the server will do is it will fill out the commit form field from your current head on the branch. The Trac has various other integration tools, the Git repositories. So there's some color coding that tells you whether this applies cleanly to the current master. Right now that might be broken because the state, what exactly is the master, isn't completely settled yet, but this will soon work correctly. And then you can click on this commits link under the branch to see commits, and click on the branch to difference. You can get diffs between different commits out of Trac.
Is there also color coding, or maybe even an email notification to participants of the ticket?
Yes, if you push to the branch, and if you push the ticket and with an already existing branch field, then there will be an email sent to everybody on the ticket, the usual way. Okay, and then if you're on, that's the uploading part. If you want to download a particular branch, then that's basically the same as the process for downloading this public sage git master. You just would fetch your username, whatever kind of description the other author would have used. And well, as just like push, and there's this pull. We have specified the remote track name. Easy. So here's a screenshot of the track for some ticket that where we worked on, and just to show you the field. So there's this branch field. This happens to be green by chance. There's this commits link. If you click on that, then you'll get more. You can both click on the branch name and on the commit, and you get slightly different information. So just try it out for yourself. And here is the actual commit SHA-1 hash. You notice it's truncated because it doesn't fit in there, but if you copy and paste it, then you actually copy and paste the full string, not the dot dot dot. That's a HTML thingy. And that's it. Let me say some words about this merging versus rebasing, because you can shoot yourself in the foot there if you do it the wrong way. So if you remember earlier, I showed you this example where we merge changes, that non-concurrent changes. Similarly, as you develop your own branch, the Sage master will change invariably, and new version comes out, and your repository will basically look like this. Now with time going to the right, and at one point you started your own branch and you did development, added commits to your own branch, and the release manager also added stuff to Sage, and the master branch advanced further. And then the question is, what do you want to do? How are you going to handle this? First of all, there's two principally different ways to handle this situation, and that's one of them called merge. As we said before, you merge those. If there's no conflict, then it's basically instantaneous. You merge, and then you commit the merge. And if there's no conflict, this is like a 5-second thing, and it creates a new commit. The other thing is that you might want to do is rebase, which means you act as if you started at this later commit in the master branch. So Git has some tool that will take your commits and then undo them and then redo them as if you made them on the most recent commit in master. But since the parent hashes are part of your hashes, this will create different commits. Now those commits are all different, have a different SHA-1 hash. There will be, of course, logically the same changes, but they have different SHA-1 hashes because the parent changed. And so the advantage of rebasing is, of course, it looks cleaner. That's the disadvantage is all that the SHA-1s changed. So in particular, if you had it already uploaded to Trac and then somebody else used one of your commits to base his branch on, then that other person is screwed, because once you abandon your old commit and change into new one. This will, if somebody was using your old X and now you rewrote into X prime, then that other person would have a ton of fun resolving all those conflicts. So, in other words, don't rebase if you have pushed it to Trac as a general motto. And fine. So if you don't rebase, then you have to merge.
Okay, but in principle, the other people have the same problem, or at least it seems to me that they have the same problem, because they would still work on top of Z. Also if you go to the next slide, they work on top of Z.
Let me go here.
And they should now work on W.
But that's fine. If I'm doing this merge, this third person has been working on Z, then that other person is just in this state where what they were depending on moved on.
And you tell me if you use rebase, then Z is definitely gone or not?
Well, it's not gone, it's still in the repository. You can kind of Git always lets you undo.
If it is not gone, then I don't see the problem.
It is or if somebody else downloaded it, then it's still there, and it will conflict with your Z prime because it's basically the same change with a different SHA-1. So you both will now, for you it looks like you want to change the same. Different SHA-1 means they're totally different commits, but they change the same kind of lines in the source code. It's a guaranteed conflict.
In other words, the teaches that we should not use rebase.
Yeah. Do not use rebase for stuff that you have published. And if in doubt, don't use rebase at all. There's a disadvantage for using merge to update things, which is pretty slight in all things. It creates an extra commit that will be in our history forever, but
And you say never use rebase for published stuff.
Yes.
If you base your unpublished stuff on something that's published and use rebase, then
that's fine in principle. If you want to clean up your history